Let's discuss scalars and vectors. Scalars are quantities that have magnitude only, whereas vectors are quantities that have magnitude and direction. When we're dealing with scalars, we're basically answering the question, how much of the quantity do you have? How much? When you're dealing with vectors, we are answering two questions, how much and in which direction. For example, how far is town A from town B? We're looking at the size of the distance. How much is the distance between the two towns? The distance is 25 kilometers. Since in this particular instant, we're not worried so much about in which direction do you take the 25 kilometers, along which path are you going to go, east, west, or south. This is an example of a scalar quantity. So distance is an example of a scalar quantity. Okay? If we're dealing with a vector quantity, we would ask this question. How far is town A from town B? And in which direction? So we're going to talk about the magnitude of the distance between town A and town B is 25 kilometers. The direction that you need to travel is in the eastern direction. So now we've got two parts to this answer. We've got the magnitude and we've got the direction. So this is a vector quantity. That's what it means. So vectors are quantities that have magnitude and direction. Scalars, if you just give the magnitude only, you've fully described the scalar quantity. Okay, that's what it means. That's the difference between scalars and vectors. Obviously, if you look at how to add scalars, you'd say, well, since scalars have got no direction, you just add them arithmetically. We say you add these arithmetically. Well, arithmetically means you just stack them on top of each other. You add them like that. 25 plus 5 plus 4. But vectors, you're going to have to add them algebraically. We'll talk about adding vectors in another vector. Algebraically means, well, you're going to add some positive and negative numbers there. You're going to have plus 2, minus 6, and so forth. That will be the difference. So scalars are added arithmetically. Vectors, you add them algebraically. Okay. Now, examples of scalars are distance, mass, time, energy, speed, area, and volume. Examples of vectors are position, displacement, velocity, acceleration, and force. Now, we're given following statements and we're asked to write next to each statement whether it is describing a vector or a scalar. In other words, is the statement talking about a vector or a scalar? So, number one, a current of 25 amps flows in a circuit. So we've got the magnitude right there. Now, we're not told in which direction this current is going. It's just flowing in a circuit. We can get the magnitude only. Okay. Now, since we've got the magnitude only, and we have fully described whatever we're discussing about the current, we are talking about a scalar quantity here. Okay. So in other words, the current is a scalar quantity. We don't need to talk about direction most of the time. We're just saying the current is flowing in the circuit. Yes, I know one can argue, but say we say it flows from the positive terminal of the circuit to the negative terminal. But you notice that the direction is not specific because it's not worth mentioning. So current is a scalar quantity. Number two says a box is 300 meters. So where we've got the distance that the box is, and then we've got a direction as well, east. So 300 meters, magnitude, east direction. This is a vector. So we're describing a vector here. Number three says a bullet is traveling at a speed of 500 meters per second. We don't know whether the bullet is going east, west, south, 20 degrees to the horizontal, and so forth. So this again is an example of a scalar quantity. Then in question 4, we have a bullet traveling at 500 meters per second, 45 degrees east of north. So in this case, we can say, well, there is magnitude given, 500 meters per second, and there is also direction given. So this is describing a vector quantity. Later on, we'll talk about a vector quantity called velocity, where you've got speed and direction together. Okay. Number 5 says a tennis ball falls 60 meters downwards from the top of a building. So the magnitude of the fall is 60 meters distance. The direction is falling downwards. Okay. So this is describing a vector quantity.